difference between a series and parallel circuit. To do this, we are going to show how to find the equivalent capacitance and charge of both type of circuits in question. The agenda is to 1, explain series and parallel circuit, 2, to calculate equivalence, and 3, to compare theoretical and experimental values of custom circuits.
The circuit mentioned is a circuit that is in a series convention. In the series, the charge goes in one particular path. In a series, every capacitor has the same amount of charge. This brings us to our equation, and it gives us our equivalent capacitance, which is down below, and it says that the inverse of the equivalent capacitance equals the summation of the the inverse capacitance of each capacitor within the series.
In a parallel circuit, the current that runs through it will divide into 2 or more paths before coming back together to complete the circuit. The total capacitance of capacitors in parallel is equal to the sum of their individual capacitance.
We're going to be working with a circuit that has both series and parallel concepts to it. These values here are the theoretical values of the capacitor in the voltage. That's either set by us or that's actually on the capacitors themselves. Using the math to find the capacitance equivalence of it, we're going to combine the second and third capacitors by taking the inverse of the sum of that total, and then adding it together with the other circuit that's connected in parallel, and our result for that equivalent is 13.197 microfarads. Now, if we go over to our experimental values, these are the values after we took we actually measured the capacitors on an ammeter, and we got a different result, a little bit similar, but it was 11.42 microfarads. So we're going to be showing you how we got these values, and eventually how that the equivalence will be the same or very similar to both of our totals we have on the board here.
It will be to compute the series portion of the circuit. As you see here, we have the 2 capacitors, and we connected them as such, which will give them a series component. And to calculate that, we'll put them in the breadbasket, and we'll get a value of 2.92, which is relatively close to the theoretical value of 3.01 microfarads. So next, we'll connect it in parallel to complete the circuit, and here we have the other capacitor, and we'll put it in as such to produce a value. And that value comes out to be 12.03 microfarads, which is also close to the actual equivalent capacitance that we got earlier, which was 11.42 microfarads. So as you see, the experiment was successful.